All right, you're going to want to see this. We just got some absolutely incredible new images of the interstellar object 3I/8. And look, this is a huge deal. Why? Because what Hubble and the European Space Agency just spotted just might, confirm a theory so wild it could flip everything we think we know about these mysterious visitors right on its head. And you can see why people are so fascinated by this thing. It's so bizarre that, get this, some polls suggest up to 70% of people suspect it might be, technological. But okay, let's put the speculation on the shelf for a minute and just look at the science, because trust me, the reality is turning out to be every bit as strange. So to really get what's going on, you have to understand that this thing, 3I/Atlas, has been breaking all the rules for what a comet is supposed to do. I mean, it's got a couple of major quirks, anomalies that have had scientists just scratching their heads. Okay, first puzzle, it's anti-tail. Now, normally, you've got a comet's tail, right? It always points away from the sun. But sometimes it looks like there's another little tail pointing towards the sun. Usually, that's just a trick of the light, an optical illusion based on where we're looking from. But not with 3I/Atlas. No way. This anti-tail has been sticking around for months, and no matter how our viewing angle changes, it's still there. That tells us it's not an illusion. It's a real physical thing. And then there's the second weird thing. This thing is just impossibly stable. The sun's solar wind, its magnetic field, it can be super violent. It can literally reach out and snap a comet's tail right off. We call it a disconnection event, and we've seen it happen to comets all the time. But 3I/Atlas? Nope. Its tail structure has stayed perfectly intact. No disconnections, nothing. It's just holding together. And here's the kicker. It's doing this during the absolute worst possible time. Right now, we're in what's called a solar maximum. Think of it like the sun having some serious mood swings. It's super active, throwing out magnetic storms and just chaotic, violent solar wind. This chaos should be shredding that comet's tail to pieces over and over again. But it's not. It's just fine. So what in the world is going on here? Well, this is where it gets really interesting. We just got two new sets of eyes on the problem, looking from completely different spots in space, and it's giving us our best look yet. First up, check this out. NASA just dropped this image from the Hubble Space Telescope. It was taken from a massive distance away, over a month after 3I/Atlas had its closest flyby of the sun. So what we're seeing here is what it looks like as it's cooling off and heading back out into deep space. And this amazing image gave us a number, a precise measurement of that weird anti-tail. It's stretching about 60,000 kilometers from the main body. Okay, I need you to lock that number in your brain. 60,000 kilometers. Seriously, remember that. It's going to be a huge deal in just a minute. Okay, so while Hubble was looking, the European Space Agency's JUICE probe was also flying by, but it saw the object from a completely different angle. And this is so important because it proves that these structures we're seeing, they're not some kind of illusion. They are real 3D features. And JUICE also saw that the plasma tail was way too clean and organized, which just doubles down on this whole impossible stability thing. Okay, so let's recap. We've got a comet that's basically doing the impossible. So now let's look at this pretty wild theory from Harvard scientist Avi Loeb that might just explain every single bit of it. He calls it the swarm hypothesis, and the idea is actually pretty straightforward. What if 3I/Atlas isn't one single object? What if it's a main body surrounded by a whole swarm of smaller fragments that broke off of it? So how would that even work? Well, picture this. The main body is active, right? It's got gas jets firing off, and they act like tiny little rocket engines, pushing it ever so slightly away from the sun. But the fragments, they're just dead rocks. They don't have any jets, so they're only being pulled by the sun's gravity. Over a few weeks, that little push on the main body adds up. It gets nudged away while the fragments drift toward the sun, creating a structure that looks, you guessed it, exactly like an anti-tail. Okay, you remember that number I told you to remember, the 60,000 kilometers? Well, this is where the theory and this brand new observation collide in just the most mind-blowing way. Just a few days ago, before anyone had seen that new Hubble image, Loeb sat down and did the math. Based on his theory, he calculated exactly where those fragments should be right now, assuming they even exist. Just look at this timeline. He figured, okay, if fragments broke off around October 29th when it was closest to the sun, then by November 30th, they should have drifted about 60,000 kilometers away from the main body. And then, just a few days after he made that calculation, on December 4th, NASA releases the Hubble image, showing a structure that's, about 60,000 kilometers long. I mean, this is the punchline, right here. He published his calculation before NASA released the image. His prediction, based purely on this wild swarm idea, was a perfect match for what Hubble actually saw just days later. You can't make this stuff up. It's about the closest thing you can get to proof that this crazy theory might actually be right. So why is this such a big deal? Well, because if the swarm hypothesis is right, it doesn't just solve the mystery of the anti-tail. It actually clears up a couple of other huge problems that have been nagging astronomers about this object. First, it explains why this thing is so incredibly bright. I mean, think about it. The combined surface area of a whole cloud of little fragments is going to reflect way more sunlight than one single object. And second, it explains the impossible mass loss. Scientists were wondering how it could be shedding so much material. Well, more surface area across all those fragments means a lot more ice can turn directly into gas. The swarm hypothesis just ties it all together in a perfect little bow. So it really looks like the evidence is pointing to 3I Atlas not being some lonely traveler at all, but a whole family of objects moving together through our solar system. And that leaves you with a pretty mind-bending final thought, doesn't it? If this interstellar visitor is really a swarm, what else is hiding out there in the dark, just waiting for us to find it?